In this module, we will start with an overview of the Primary Flight Display, or PFD. Next will be the main components and controls associated with the PFD. Then we will examine what indications are presented to the pilots on the PFD. These indications will be broken up into types of information. Finally, we will take a brief look at some of the flags and messages that may appear on the PFD. The primary flight display is designed to provide the pilot with all the information and guidance needed to fly the A320. The primary flight display is often referred to as the PFD. Flight mode annunciations are provided across the top of the instrument to keep the pilot aware of the current status of the automated flight systems. The left side of the PFD is devoted to airspeed information. The right side of the PFD displays altitude and vertical speed information. The center of the screen displays attitude, flight director guidance, and radial altimeter information. The bottom center of the PFD has a compass card that displays heading, track, and ILS information. The bottom left of the PFD shows the Mach number and ILS information. The bottom right of the PFD shows the barometric altimeter setting. The selected altitude or flight level is on the top right side of the PFD. The display units used for the ND and the primary flight display, or PFD, may be exchanged. This would result in the former PFD screen displaying ND information and the former ND screen displaying PFD information. There are two PFD screens. Each pilot has an Electronic Flight Instrument System, or EFIS, control panel. Each panel is divided into two parts. The outboard section provides some control for the PFD, while the inboard section controls the ND. Brightness and turning the screen on or off is controlled by a PFD control knob. There is also a transfer switch that is used to swap the ND and PFD screens. Display management computers, or DMCs, acquire data from various sensors and onboard computers and send it to the display units. Each DMC has two channels. One channel is devoted to the ECAM and the other provides EFIS information. The DMC switching selector allows the crew to select the spare DMC if there is a failure. Some indications appear only on the ground or very near to the ground before landing and will disappear after takeoff. A Maltese cross appears after the first engine is started and only while the aircraft is on the ground. It indicates that there is a direct side-stick relationship with the flight controls and what the combined side-stick inputs are currently commanding. 4 90-degree corners around the periphery of the PFD indicate the maximum side-stick deflection. A ground roll guidance command bar provides command steering ordered by the flight director to maintain the runway centerline. Across the top of the PFD are the flight mode annunciations, or FMAs. They are divided into 5 columns and 3 lines are possible within each column. From left to right, the first column displays the current autothrust mode. The second column displays the autopilot or flight director pitch modes. The third column presents the autopilot or flight director lateral modes. The fourth column shows the approach capabilities and the decision height or minimum descent altitude if one has been entered. Finally, the fifth column has the current engagement status of the autopilot, the flight director, and autothrust. Attitude information is always displayed on the PFD. There is a fixed aircraft symbol outlined in yellow that is centered in the display. A roll scale is across the top of the attitude display. It has markers at 0, 10, 20, 30, and 45 degrees of bank. A yellow roll index indicates the current bank angle. Below the roll index is a side slip index. It performs the same function as a traditional ball. It is yellow in color, but will change to blue and become a beta or a side slip target in the event of an engine failure and the flaps are in configuration 1, 2, or 3, and the engines are at a relatively high thrust setting with a significant difference between the engines in ones. The pitch scale has numbered markers every 10 degrees between 80 degrees nose up and 80 degrees nose down. There are smaller unnumbered markers every 2.5 degrees between 30 degrees nose up and 10 degrees nose down. Large red arrowheads are displayed to indicate that the pitch attitude has become excessive. The arrow points in the direction required to correct the excessive pitch. There are flight control protection symbols that show the limits of bank and pitch. The bank symbols are green equal signs at 67 degrees of bank. The pitch limits are displayed at 30 degrees nose up and 15 degrees nose down. If the protections of normal law are lost, the symbols are replaced by an amber X. Airspeed information is presented on the left side of the PFD. The existing airspeed reference line is a yellow index line that indicates the actual airspeed. The airspeed tape moves behind the fixed yellow line. A speed trend arrow will emanate from the actual airspeed reference line. The tip of the arrow shows what the airspeed will be in 10 seconds if the present acceleration rate is maintained. A target airspeed pointer points to the target airspeed or Mach value. It will be magenta if the speed is managed by the FMGC and blue if it is selected. If the target value is currently off scale, the selection will be displayed as a numeric value either above or below the speed tape until the target value may be displayed as a pointer. Econ speed magenta brackets will appear if the aircraft is in the descent phase with the Econ auto speed mode active. The normal scale range is plus or minus 20 knots. If a speed limit or speed constraint is active, the upper range is limited to econ speed plus 5 knots. The aircraft uses the speed margins it has within the brackets to maintain the descent path. The target airspeed is indicated by a magenta equal sign. Extending from the top of the speed tape on the right edge is a red and black strip. The bottom of the strip indicates the maximum speed for the existing aircraft configuration. It will display the lowest of VMO MMO, VFE, or VLE. A green overspeed protection symbol is shown at a value of VMO plus 6 knots. This is where overspeed protection will engage. Extending from the bottom of the speed tape is the low speed, high angle of attack strip. The top of the amber strip is the lowest selectable speed, or VLS. This is the slowest speed that the autoflight and autothrust systems will fly if they are engaged. This value is a dynamic number that is computed by the FACS. It is based on airplane configuration and load factor. Alpha protection is the next speed depicted. It is defined as the top of the black and amber strip along the speed scale. It is also called the tip of the tiger tail as a descriptive value. This is where alpha protections activate. Alpha maximum speed is the top of the red strip. This is the speed that corresponds to the maximum angle of attack before a stall will occur. This speed is computed by the FACS. If the aircraft is in alternate or direct law, VLS is still available. The only other low-speed warning strip that is available is the stall warning speed, which is the top of a red and black strip. This speed is computed by the FACS as well. There are a number of speeds that appear on the speed tape either as a result of the flap setting or because they were entered by the crew in the takeoff performance page. A blue numeral 1 represents the V1 speed that has been entered in the MCDU. It will disappear after takeoff. A blue circle represents the VR speed that has been entered. It will appear during takeoff while the aircraft is still on the ground. V2 is represented by the magenta target speed. It is entered in the performance page of the MCDU. Note that the speed reference system will not engage on takeoff if V2 is not inserted. A green F speed indication will appear if the flap selector is in position 2 or 3. It represents the minimum speed to retract flaps to position 1. It also is the speed that the aircraft will fly in the approach phase when flaps are in position 2 or 3 and the speed is managed. A green S speed indication appears when the flaps are in position 1. It is the minimum speed to retract the flaps to 0. It is also the speed that the aircraft will fly in the approach phase when flaps are in position 1 and the speed is managed. An amber equal sign shows the maximum speed to select the next flap position. This is a structural limitation and operators commonly subtract 10 knots from this speed to guard against flap overspeeds. A green dot is displayed whenever the flaps are retracted. It represents the best lift-to-drag ratio speed. Below the speed tape, the current Mach number will be displayed when the Mach is greater than 0.5. On the right side of the PFD are the altitude and vertical speed indications. The altitude indication consists of a white moving scale and a green digital readout with a yellow box around the current altitude. The flight warning computer will cause the yellow box to change to amber and pulse when the aircraft approaches a pre-selected altitude, or if the aircraft deviates from the altitude selected on the FCU. A chime will also sound. The landing field elevation is indicated on the altitude tape by a blue bar. A red ribbon driven by the radio altimeter is displayed on the right side of the altitude scale. The red ribbon is a ground reference and will be in the middle of the altitude window when the aircraft has touched down. The red ribbon appears when the landing field elevation is within the altitude scale display range. When the aircraft is in the descent or approach phase of flight, a vertical deviation indicator will appear to indicate the aircraft vertical position relative to the computed VNAV path. It is a magenta circle that is most often referred to as the VNAV donut. If the donut is at full-scale deflection, it means that the aircraft is at least 500 feet above or below the path. The progress page in the MCDU must be consulted in order to obtain an exact deviation value. If the path indicator is even with the current altitude, then the aircraft is exactly on the computed path. The vertical speed display has both an analog pointer and a digital indicator. The pointer is normally green and indicates the current inertial vertical speed. The maximum scale range is 6,000 feet per minute. A digital indication shows the existing vertical speed as a digital value. If rates of descent become excessive, the pointer and indicator will change to amber. Radial altitude is displayed if the aircraft is less than 2,500 feet above the ground. It is displayed just below the attitude indicator. It will change in value every 10 feet until reaching 50 feet, then every 5 feet until reaching 10 feet, then every foot until the aircraft reaches the ground. On the bottom right of the PFD, below the altitude tape, is the barometric reference that is currently being used. If standard, the current FCU selected altitude is located just above the altitude. The bottom center of the PFD displays heading and track information. There is a compass card that displays approximately 50 degrees of the sector in front of the aircraft. A fixed yellow reference line above the moving card shows the current heading. The selected heading or track index is a blue pointer that indicates the selected heading or track. If the selected value is off scale, the pointer is replaced by the actual track. ILS course information is shown on this card as well. A magenta ILS course pointer will be displayed on the compass if it is on scale. If the course is off scale, a box with the course displayed digitally in magenta will appear to the left or right of the other ILS information is displayed to the left of the compass card. The ILS identifier, frequency, and DME, if available, will be shown. Guidance and flight path information is also shown on the PFD. The flight path vector, or BIRD, indicates the lateral and vertical trajectory of the aircraft. The lateral scale depicts the aircraft track, while the vertical scale shows the aircraft flight path angle. Guidance is provided by two different flight director modes. When heading vertical speed is selected as the basic reference, the flight director displayed will be two crossed bars. This is a dual Q system. The horizontal bar provides pitch guidance, while the vertical bar provides roll guidance. The pilot applies pitch and roll inputs to center the guidance bars, and the aircraft flight path will comply with FMGC commands. If track flight path angle is the basic reference, the flight director displayed will be single Q guidance, meaning that a single symbol provides both pitch and roll commands. The pilot applies pitch and roll inputs to align the wings of the flight path vector symbol with the director and center the circle in the middle of the director within the body of the flight path vector symbol. When this is done, the aircraft will comply with the FMGC commands. When an ILS approach is flown, the ILS button on the EFIS control panel is selected. An ILS message will flash amber if the approach is armed but the ILS switch is not selected. Selection of the ILS button puts a glide slope and localizer scale on the PFD. When a valid signal is received, deviation indexes will appear. If the deviation index is off scale, the symbol will be at full scale deflection and only a half a symbol will appear. If the deviation is too great during an approach, the scale on which the deviation exists will begin to flash to call the pilot's attention to the deviation. When the aircraft passes marker beacons, appropriate letters will flash in the bottom right of the display. The indications are OM in blue for the outer marker, MM in amber for the middle marker, and AWY in white for the inner marker or an airway beacon. Although VOR, NDB, and GPS non-precision approaches are flown very much like an ILS approach on the A320, when the approach button is selected, a vertical deviation scale and index will appear. The scale has graduations representing 100 feet with a scale range of plus or minus 200 feet. The index is rectangular in shape and is usually referred to as the brick. If the ILS button is pushed, an amber vertical deviation message flashes above the vertical deviation scale. There are 26 different flags and messages that may be displayed on the PFD. A failure or degradation of any function that is available on the PFD is indicated to the pilot. A few of the major flags and messages are mentioned in the remainder of this module. In the event the PFD loses all attitude data, attitude will be displayed in red in place of the attitude display. The FPV flag will be displayed if either the drift angle or the flight path angle information is not valid. An FD flag in red will appear if the flight directors have failed. A check altitude amber flag appears if there is a large enough difference between the captain's and first officer's altimeters. A check heading amber flag is displayed if a difference greater than 5 degrees exists between the captain's and first officer's heading indications. Wind shear will appear in red if a wind shear is detected by the FAC. Wind shear ahead will be shown in either red or amber depending on the alert level if a predictive wind shear event